421 slope stabilization and Pine Mountain using a tieback wall. Our presenter will be Aaron Wallace. Aaron has been with the cabinet since 2008 with experience in construction, both D7 and D3. Is currently at the Geotech Ranch. He's been there since 2019. If you'd like to see his full bio, it is available on the app, but I'll go ahead and turn it over to Aaron to get started.
All right, thank you very much. As he said, my name is Aaron Wallace, and with the currently with the Kentucky Transportation Cabinet's Geotechnical Branch. And was anybody in here for the last presentation? I think everybody's left. This won't have near as much meaning. But I was with District 3 in the section office that handled that project, and I left right about the time that they started designing it. So looks like I missed a pretty tough one, but I think they've done a pretty good job with it. But the project we're going to talk about today is a tieback wall over in Harlan County on US 421. That was a result of the flooding that occurred in 2019, I believe. So for any of you all that aren't too familiar with the location, Harlan County is in the far southeastern corner of the state, and very challenging terrain, to say the least. Nobody's ever been over there. I recommend a trip at some point to visit the area in general. So I'm from District 3, Bowling Green, Glasgow, that area. And all of my life, I went to work for Geotech. I thought Kentucky stopped at the I-75 corridor. That's anytime you ever went east, you went to I-75 and went north or south from there. But there's a lot of the state over there, and I've enjoyed getting to see a lot of it the last 3 years working with Geotech, and continue to. But you see the location of Harlan County there. The next slide, we'll zoom in a little closer. This is the aerial Google Earth map of the location. And the city of Harlan is right here. Then you have the Pine Mountain Range that kind of runs north of Harlan there. And the project site is actually located on the other side of the mountain, where you can see this see the circle here. So although we say it's in Harlan, it's kind of on the other side of the mountain of Harlan, as you can see in the photo or in the image. Zoom in a little closer here, and the circle there on the center of the screen is your project site, where the actual 421 corridor is at, and the circle near the bottom of the screen, got to get used to this, is an active rock quarry that is above the site, above the landslide. And you can see the pit there continue to be mined. It's one of the few limestone sites sources in the area, so it is highly active and a very important resource to the area. But a little bit about the project history. This is a picture of the roadway here, kind of the area where the slide occurred, and this is at mile point 22.85 on US 421 there in Harlan County. And the slope failed following a large flooding event that they had in 2019. And I wasn't with the Geotech branch at this time, wasn't very familiar with this part of the world. But there was a presidential disaster declaration for this part of the world, or for this part of the state, and what actually caused this slide. And a lot of this movement occurred pretty well overnight. I think they came in the next day, and this is pretty well dropped and moved. And we've got a better picture of the roadway here, but this looks like a fairly small road, a rural road, but this is a fairly major connector in the county of in Harlan County, with the quarry we mentioned, and there's also an asphalt plant there close, maybe a concrete plant up in that area. I know for sure an asphalt plant. So it looks like a small narrow roadway. This is not just a small secondary road that can easily be closed down. It's very important for people accessing across Pine Mountain there to have this corridor open. So it was a big deal when this slide happened and affected this roadway. And to my knowledge, this section of roadway has not been closed down very long during this entire process. It was what little temporary patching work had to be done was done then to keep it open, and keep traffic on it. So just keep that in mind as we look through some of the photos here in the presentation to come. So this is a picture of the roadway standing up grade and looking down it. And you can see it's fairly steep. It's 6% roadway or profile grade. And there was some signs of sliding, and you can see the slope here behind the guardrail. Those are not your nice 2 and 3 1 designs that are stable. They're very steep. You see the guardrails dipping, the utility poles were leaning, and you know, this area was definitely moving and showing some movement, and you can drive all up and down this corridor, and it slides all up and down through here. So it was no real surprise. It's literally in a bench on the side of the mountain. So when the slide eventually happened, there was a quick repair estimate put together of around $6 million to fix the slide in this area. Again, this is affecting a very short section of roadway. I think the wall only ends up being about 700 feet long. But when it was initially called in, the thing that the geotech branch goes through a lot is either soil nails or rails, you know, drilled in railroad steel. You all have ever seen that. But after a little bit of site investigation, it became clear pretty quick that the sliding resistance of either one of those or a combination of those two repairs could provide was not going to be anywhere near the capacity that they were going to need in this location. So the Transportation Cabinet and FHWA worked together to find a permanent solution and use the emergency relief funds based on the presidential disaster that was declared on this project mentioned earlier in the slides. And after looking at it, our branch made a recommendation that this area needed to have a soldier pile and tieback wall installed here, which a lot of it is because and we'll show some slides here in a minute that shows how much mountain we were really holding back, and the rock was deep. Rock wasn't all that great, so you had a lot of factors working against you here. The district, it says KYTC, is actually, I think, mainly the District 11, investigated relocating the road up the hill onto the Portage property. We'll show it again later on. The rock quarry that we were showing above owns both sides of the roadway here. So anything you wanted to do off right away had to go through them and couldn't affect their operations. But so moving the roadway into the hillside and getting more property from them was pretty well off the table. I don't know, I wasn't around for those talks, but I think they were pretty short-lived. So as this happened, KYTC continued to monitor the movement, and they continued to patch this. This is the district, the maintenance crews. Because, as I mentioned, this pretty well had to stay open. You know, if that meant it needed to patch twice a week or whatever it took, then, you know, they had to just continue to patch it. Of course, it was actively sliding, so it was continuing to need those patches. And then District 11 worked with the Division of Maintenance and our branch to develop a contract document for a July 2021 letter. So that's if you paid any attention to those dates, this happened in February of 2019, and we left the contract in July of 2021. That's a long time, but it took a fair amount of monitoring and drilling and that sort of thing to actually define where the slide was, what we were holding back, and what it was really going to take to fix this. I said it on the presentation earlier about the bridge in Memphis that they fixed over the Mississippi River. And they were talking about from the time they found that crack in the bridge to the time they started their repairs, it's 11 days. We did not hardly meet that time frame with this one. So the geotechnical exploration, and I want to mention this before we go any farther. This project was the design, the monitoring, everything was completely handled in-house. There was no consultant design, no, KYTC handled the whole thing, mainly the geotechnical branch working with the district and with maintenance. And, so this is actually our drill crew here, our drills, our trucks, our employees, taking some of the borings here that they've done on their exploration of the project. And we done quite a bit. It was drilled in 3 separate phases. Phase in 2019, which included 23 rock soundings and 1 coring. And that was when we were kind of in the initial soil nails or railroad steel repair mindset. And those typically are based off rock sounding depth. So you see a lot of rock soundings there. Phase 2, we came back. We done a few more rock line soundings and a lot more corings and soil sampling. And we also installed 8 sloping kilometers and 4 observation wells during this drilling. That was when we reached the point that we realized we were going to need a lot more information. We were going to try to have to define the slide area and the slide location and the actual forces and that sort of thing that we were dealing with. And then you see there in 2021, we went back and took 3 additional rock core borings. And that was due to a certain area in the rock line that we thought there might have been a mistake and that our borings may have been off. And these were just verification borings to go back and check that. So in total, you're right at 60 borings that were taken on this project. And anybody that does design work should be super jealous of this next map when I show you that we have 80 borings, whatever I just said, 60 borings within this footprint right here. But one of the most important things we put in on this project, and I'll point out a few of them here, you'll see some of these boreholes with SIs denoted next to them. We've got them up here, several right above the road. There's 2 in the roadway right here, and there's 1 below the roadway. So these are what we were using to truly monitor how much movement we were getting in this area, and to define our slip surface and how big of an area we were holding back and what we were really dealing with here. And again, this is a nice plan view of these borings in the area, and we'll try to show a little more of the terrain and where all these are located. The initial borings and soil classifications that we brought back showed a little bit of everything as far as the soil. There was really nothing, this wasn't just a true clay or a true sand or any of those easily classified soils. They were rock fragments, cobbles, floaters, boulders. Then there would be some soil. I mean, it was just an absolute hodgepodge of everything. And then when we got down into the bedrock, of course, in this part of the world, there was mostly shale there. 2 main formations, the Chattanooga and the Granger. The RQD numbers there fairly low. The rock wasn't coming out all that great. It wasn't super strong. You can see the compression strength. The averages for the Chattanooga and the Granger there. Not just horrible, but not the greatest in the world. But it's what we had, so it's what we had to deal with going forward in our design. So the next thing I want to show you is or talk about is the sloping phenommeters that we installed. So there was a total of 8 of them on the hillside, and we monitored these. The first reading is a straight line, the 0 line on both these plots, and those were taken on September 28, 2020. That was right after they were installed, and they had a little time to set. And so we read these. We would read these every month, 2 months in the initial phase of the project. And then when we would get to the winter months, February and Marches, all of a sudden you would see this line shift. And that's showing your hillside movement, your soil mass that these inclinometers are in shifting. And then you would go for a while and the line would stay together. Then you would come back again in the winter months. These are this pink line here is a May reading, and you would see this slide again. But the real surprising thing is this was our rock line in this particular inclinometer. And the movement was several feet above it. You would expect your soil to be sliding right on your rock line. And that's the assumption we typically make. But it was not the case here. And when we had these inclinometers to back this data up, it really helped us in the design phase to know what we were going to need. So at the time of letting, this SI was read last in June before the contract let in July, and they've been in less than a year. As you can see down there on the bottom, you're showing 3 inches of displacement in that SI in less than a year. So that means your hillside where we had monitored had moved 3 inches, which doesn't seem like a terribly large amount if you know, depending on what you're doing. But the surprising thing again was it was 9 feet above the bedrock. So we continue to monitor these, and we continue to monitor them now, all of them that we can. And right now, these are the most recent ones we had, and these were from the letting date to just last month, or a couple months ago. We had seen an additional 2 inches of displacement in the field side and 5 inches of total displacement. So since we've been monitoring this mass, we've seen it move down the hill 5 inches. Again, 9 feet above the rock line. And picture over here on the right, that's the access road to get to one of the SIs to measure them, and it's a bit treacherous to get there from time to time. I think our gator is hooked to a tree with a winch and drug up the hill right there, trying to get us up there hill. Definitely a tough terrain challenge. So when we talk about these inclinometers and we talk about the movement, seeing 3 or 4 inches in them, the one that I just showed you the readings on is SI number 4 right here, driving the roadway. SI 4 and 8 are both in the roadway. The surprising thing that we would see is, here's 2 in the roadway, here's 5 above it, 1 below. And you can just about bet your lunch or your paycheck or wherever you want to. If you see an inch right here, you can see an inch right here. If, whatever one he moved, the other one, all the others were moving together. So it not only showed you that your roadway was moving, but it showed you the whole hillside was moving that entire, that same amount. So that really led to the driving forces, the type of material that you're trying to hold back with this wall design. So this is the Google Earth map again, get everything oriented. Here's your quarry up here. Here is the SI that we had the highest up the hill. It's not marked. Here's your roadway. Here's the lowest. So we were able to find the sliding mass in this shape right here. In the direction it's moving almost truly north. And from the top SI to the bottom is 800 feet of hillside that we're able to monitor with those 2 SIs. And again, from the SI on the bottom to the one on top, the slope inclinometer, there's a 300-foot vertical elevation change. So it's a fairly steep hillside that you're seeing that right there. And then you're affecting about 700 feet of roadway right here. So that ended up being really close to the length of the wall. But based off the inclinometers and all the other soil data we had, we were able to find this area as the mass that we were trying to resist to. So it became quite a big problem. You could really see how big it was. And this is the cross section. Get a little better idea of the scale and what we were dealing with here. So the green line, you can see the red is your rock line, and based on the SI of this station, there were 3 of them right at the station. So we could define our sliding mass above the rock line. And we knew how much was moving. We had all the geometry on it based on the survey data. But if you want a little scale, there's a 24-foot roadway, and in that slide, there's your roadway right there. That little flat green spot down in the bottom. So it's a pretty big area that the roadway is a very small part of in this area. And again, back to the right of way issue, you only had 90 feet of right of way through there, and the quarry was the owner on the uphill side and the downhill side, which if you could get them to agree to anything, it's good because they own both sides and right of way wasn't an issue. But if you couldn't get them to agree to anything, then you had a problem because you couldn't go across the road. But for the most part, they were pretty good to deal with as far as allowing access and that sort of thing. So our proposed solution was to build a soldier pile wall down just north of the roadway, on the downhill side of the roadway. And we would end up, based on the final design, we'd have a soldier beam every 8.5 feet. And they are embedded in rock, and those rock depths change. They're anywhere from 12 to 20 feet, depending on the loading. And that rock cycle was in backfill with Class B concrete. So that's how they were anchored. That's how you actually anchored your pile into the ground and held it. And that's a pretty stiff system, but again, with the modeling and what we were checking, it still wasn't enough, so we had to add the tiebacks into it. So the way a tieback wall is built, is you go in through the beam, and you drill these anchors back into the rock, and the anchors are grouted into the rock. And every anchor that is installed is tested to ensure when you're pulling on and testing them, you're ensuring that this bond back here, when you drill them into the rock, is holding and anchoring and giving you the resistance that you truly need to resist what's pushing on it up here above. And it changed in different areas of the wall, but on average, each anchor was resisted and tested to 340,000 pounds. So they're, and that's a beam every 8.5 feet with that much resistance. So they're holding a lot. So there was a pre-bid meeting on this, and bid on a project like this with KYTC, you were required to come to the pre-bid meeting. That way we could ask any questions up front, and we knew who was going to bid and had an idea of how many bidders we were going to get. When this finally went to bid in July 2021, we had two. We had Richard Gettle at 5.8 million, and we had Schnabel Foundation Company at right around 9.3 million. And the contractor was awarded to Richard Gettle because of their bid was, they were just 1.5% underneath our engineer's estimate. That made us feel pretty good in our office that we had, that we had called everything, and you don't like to see them when they're, especially on kind of a specialty project like this, you don't want to see them 50% over what your number was. Makes you wonder if you missed something. So a little bit of breakdown on how these jobs are bid. They're somewhat of a design build where the contractor is given a set of units to bid on, but they're not given the true design. They're given the loading that they have to resist, and they're given some parameters that they have to accommodate in that design. But the final design, the pile height, the pile spacings, the anchor lengths, all that sort of thing is on the contractor to actually submit us a final set of plans when they construct a wall like this. So going through these quickly, they did the square footage of the walls was 3.7 million. And you got a bunch of other items here that were associated with the retaining wall itself for a total wall cost of about 4.4 million. And then you had your guardrail, paving, et cetera, add another 1.5 million to get us to our final bid price of 5.8 million. Roughly exactly what the number is there. So this is what the contractor submitted to us as, of course, there's more plan details on this, but this is your main wall, your main plan sheet. You see your assumed rock line is right here in green. And then they have all these piles installed, drilled into the rock socketed into that rock line at a calculated depth based on the loading in each one of those walls, or each one of those the sections in the loading that we were given them. So it's a pretty busy set of plans, but it's also pretty impressive that $6 million worth of work fits on one plan sheet. So that is the entire wall on that plan sheet. Now, there's a lot to make that happen, but, that is that's the actual wall profile sheet there. So real quick here, if you've never seen a tieback wall constructed, it's a little hard to wrap your head around. You start initially with just pretty well your site, whatever you show up on, maybe a little clearing, a little final grading. And the first thing you do is drill the beams into the rock cycle. And you get this beam installed, you get it anchored into the rock, you get it backfilled with Class B concrete. And typically what they'll do is wherever your rock line is, you will fill this with concrete, and then from the rock line up, you fill with flowable fill. That's what we spec'd out on this, and that cavity had to be refilled or they had drilled out. So a lot of the flowable fill ends up being taken back out as they excavate this wall down. That was new to me. That was quite interesting to see how that process worked. Once you get all your beams, or at least get some of your beams installed, you go in and you start excavating the front face of the wall. And once you get down to a certain point, and as you're excavating down, you're putting in temporary lagging, because you're putting lagging boards in between these soldier beams, and that's why you have to backfill those with flowable fill, so that when you need those lagging beams in, you can excavate that flowable fill back out where you need it, but it fills that socket in and remains in place where you don't. So you get down to a certain point, then you'll put your first row of tieback anchors in. Those anchors we were talking about in that cross section that was plus 300 and some thousand pounds of resistance on them. You'll create a bench out here and install those back into your rock line underneath your roadway, wherever that is. Once you get your wall anchored off and locked off, you will continue your excavation down and bring your lagging boards down as you go. Again, in between each soldier pile or each beam, so that you're holding the soil back behind your wall as you're going. You get down to a certain point where your second row of tiebacks is, if you have a second row, which you did in this case, and you install your tiebacks again, complete your excavation, and then you come back and you put a permanent facing from the bottom up to complete your wall. So all that with some pictures, maybe it'll make a little more sense. So to get a rough idea, these are your beams that the contractor elected to use based on their design for this job. And they varied in length depending on the depth of rock. But you can see they're two individual sections of beam, and they're welded and spliced together to make one rigid unit. And you see the holes in here, these are where your tiebacks are installed through once the beam is put in. And then they're working on a frame here, the staging area. So this is about step 3 of what we were showing there a minute ago. You've installed all your soldier beams, you've excavated your bench down, and now you're putting this temporary wood lagging in between each one of them. And as you can see there, these guys over here are working, getting the lagging in. This guy on the excavator, he's taking the material on out, and as they take it down, you have to lag that in to continue to hold that hillside as you go down and keep your wall behind it, or keep your soil behind your wall. And as you can see, it's not small equipment that it takes to do this. You know, this whole job was crammed on the side of a mountain, literally. You know, this is the roadway right here. You can see the back slope, and that's a pretty substantial crane that has to be in there working because of the depth of the bedrock and the length of the beams that you had to set in the hole in each one of the sockets. You had to have a big crane to be able to get them in there. Again, just explaining the pieces of it there. You can see the soldier beams, the temporary lagging going in between them. And here is you've got a drill rig sitting down here on your bench now, and these guys are drilling your anchors, your tieback anchors that go through the beam in your rock socket holes that are actually holding your wall, giving you the additional resistance that is needed. And then they had their own grout plant on site that as they're installing these anchors and grout, and they're batching the grout right here. It's not out of a ready mix grout. It's small batch mixed on site. It gives them the quality control if they see issues. they can change it quickly. They don't have to rely on a concrete plan or that sort of thing to try to fix what their, any issues that they're having. And the bond is a really important part of this. So their grout is extremely important, and the quality control on it is extremely important, because where we're gonna make them test 100% of these anchors, if one of them is bad, and we're gonna see it in the testing. So they have to be confident that their grout and the quality of it is good, and what they're putting in is gonna hold. This is just this is another angle of the wall. This is where you're working on your next phase. You got all your beams in, you've got your lagging in, and you can see right here, these plates have been put in. So your anchors have been installed, they've had the tension pulled on, and they're locked off. You have your first row completed, and your excavation is continuing down to your next row of tiebacks, and eventually the bottom face of the wall. Keep explaining all this in the slide, explain it for you. But this, to me, this is one of the absolute most telling pictures of this whole job. This is a US route open to traffic during this job. This is serving a quarry and an asphalt plant on a 6% grade in the middle of winter. And this is the roadway that they had to use for access. And the only reason they got this width, you can see, I think I got a little better picture later. This is all demonstrated up there. And the contractor came in with the geogrid in the ditch, built the ditch in to widen the road over, to put the traffic literally against this bank to get 10 feet of clearance for the project. And they've got a lot of the big equipment out now. This project is still ongoing, and they've probably opened the access up to 12 or 13 feet of width now. But you want to talk about, it's not our office, the district office gets a lot of phone calls. There were a lot of people that were not impressed with this, but again, it was the absolute, it was the only solution that we knew of, or that the contractor came up with, that would keep this road open. So it's barely open, but it was open, and it was passable, and it was, you know, it was dump trucks, coal trucks, asphalt trucks, whatever you can imagine. It wasn't just pickup trucks going up and down through this project. Of course, the stoplight in each end where there's only one lane. A few more just project photos here. This was November of last year, and I'm pretty sure this was the day they installed the first beam. So this is their staging areas up here where they're bringing this drill rig out. And these photos are taken in the same place. This one's looking uphill, this is downhill. So they would leave all their beams here, and then individually they would have to be packed down this roadway with a skid loader, an excavator, whatever piece of equipment they had, and take it to the drill and drop in the socket. This is a very short one here. A lot of them are long enough they had actually just dragging down the roadway. They couldn't turn sideways to get them back. Here's a little better picture of this is their shoulder widening. I think this is the first day they got it done, so it looks really good and looks really clean. But any of you've ever seen dense grader in the wintertime with some traffic on it, it gets pretty nasty pretty quick. And they pretty well kept the guy on a bobcat all day while they were working, keeping this field in, graded down, but just trying to keep the access up and down this corridor the best they could. And this next one, they had some pretty high completion dates on this based on the sloping thermometer data that you're seeing. We knew when the movement happens, it happens in February and March. So this is December here, and they're just now starting to get those, get their soldier piles in, or their beams in. And it was phased where those needed to be in by February or March. So they worked through some pretty tough conditions out there throughout the year. And again, a roadway we've been talking about so much, you can see it's right here on top of the wall. You know, that was the roadway that remained open. You can see this mud just everywhere. This drilling requires water. As that drill is going, it's blowing soil cuttings back out. So with the muddy ground and the soil cuttings coming out, it's just making mud piles everywhere. These guys are probably standing close up to their knees, and in mud down here working around this. And this picture is February 22nd. This picture was taken. So the wintertime shutdown did not happen for these guys on this project. Just couple more quick photos here. We were talking about testing the anchors. This is standing on top of the wall, looking down, and you can see your anchor strands sticking out here where those have been grouted into the bedrock. And this is the jack that they use to put a specified load on each one of those to test them. Once that jack pulls on, there's a set of wedges that go right here in this plate, hold those cables back at a certain tension to keep that wall locked off, whatever the design requirements were. This was in March, so it was looking better. And this was in June of this year. You can see all your anchors are in, all your soldier piles are in, and they've started at the bottom, building back up with their permanent lagging, the permanent concrete lagging will be the final face of the wall. Here's a little cross section of how they fill that gap in between the wood and the concrete. You can make sure there's no voids in between there for the resistance. And then this photo right here was taken August 22nd. So that is getting pretty close to completion right there. As you can see, they removed all the equipment from the top of the wall. The lane's opened up wider. It's still one lane with a stoplight, but it's a lot better than when it's crammed over to the side. And they still like the cap on it and the final paving in this photo, but that's pretty well as recent of a photo as we have of what the final wall will look like. Yeah, it goes on around the corner to about where that excavator is down there. That's roughly about 700 feet of wall, $6 million right there in the spot. And this is one of my favorite photos for this job. This is up on top, not quite the top, but up above the quarry. This is you can see the quarry stockpiles. This is that pit that I've shown in several photos. Just the view from the top and the rough terrain to get to, but it's a pretty nice view when you get to the top. So that's all I've got on it. Does anybody have any questions about it?
What's the diameter tiebacks?
Of the actual cable tiebacks, there was. I'm gonna get this confused with another one because we're building another one of these right now too. I want to think they use that. It's an 8 or a 10-inch hole that they drill. That's the hole you see drilled to install those in. And then the actual tieback diameter depends. There's different sections of the wall that have different strands, a different number of strands in each one of the tiebacks. So your pilot holes, I think, are 8 inches. The hole you drill and get the tieback in. And as your wall loads got higher, you end up with more strands in your anchors themselves. So I think some of the lower ones, you had 6 or 7 cables in there, individual cables about the size of your thumb. And then as you got into the higher loaded areas, you would have, I think there was 11 cables in some of those parts. Again, the same size cable, just more of it. Does that answer your question? Okay. Anybody else?
Was there any contingency in that bid, $6 million?
As far as?
Well, from your bid, obviously the contractor bid, you're gonna hide that. You always put a contingency.
No, there was, where it was, like, I mean, those are addressed by change order if needed, all your unexpected items on something like this. It's bid in the same format of, a design bid build. So when items come up, and there were several of them, they're just typically addressed as a change order type item, not a. Yes.
I thought in your estimates, you physically had, when I did the math quickly, I thought I saw that the engineer's estimate actually had put, there was maybe $800,000 worth of cable between the first number and the second. Maybe there was something in there. My question had more to do with the inclinometer in 2022.
Yes.
You get all that data before. and you were trying to get in and get all your piles in before spring of this year.
Mhm.
Did you take any data this year?
Yes. These are to June of 2022, the second file was. We actually went back and read these last week. Some of the ones in the roadway, we can't read them anymore, and we think a lot of that's due to construction, they were probably hit with the tiebacks and the droughts got in them. The one below the roadway was lost during a small slide during the job, so we haven't read it since late 21. But all the ones above the hill, we're actually showing very little movement or stable now. And there's a post-construction monitoring program that will be ran by us. The contractor installed 3 inclinometers in the wall right on the beam. We're going to go in and put 2 below and 3 above that we will continue to monitor throughout the life. Well, I don't say life, but the next several years of this wall to ensure that that it's not showing any movement. We have held back. We need to go back a little bit.
Incidentals. I don't know if you had anything in there.
Well, those were all items that were bid though. But each one of those items had a bid price associated with it. We just, in geotech, we consider those incidental highlights. They each one had a unit price associated with them. So that, they submitted us a final number of 5.85 million. Anything else?
Out of curiosity, any concerns that as the quarry gets closer to that hillside, that I assume they're using explosives for their operation, any concerns that the vibration is going to instigate more movement?
No, there is some concern though. We try really hard not to mention this, but since you asked, we'll talk about it. If you can look right here, you can kind of see the trees are gone. There's a lot of rocks. About the size of these tables. The quarry wastes a lot of material off over the side of this in their blasting material, in their blasting operation, and they continue to do so. They continue to do so enough that when you go read this SI, you go talk to the quarry and tell them you're down there so they don't kick a rock the size of a Volkswagen off of the hill at you. And there's about 4 of them the size of a car laying within 10 feet of that SI pipe. How it survived all that time and they have a rock hasn't bounced off to hit it, I don't know. But, yes, there's a lot of concern that's part of the reason why the loads are as high as they are, because we know that the process will continue and that will be there to resist long term.
Yeah, one more. This will be the last question.
I don't know. Nothing we screwed up. No, in all seriousness, not really. They had, not that we're aware of, but the district construction office handled it. There were a few small changes. They've done a lot of stuff at the top of the wall, the final grade. This area right here is supposed to get a concrete cap on it. It's going to end up with a steel beam welded on the outside face, and they're just going to pave up to it. And there's been some back and forth changes on, they're going to have to change the asphalt grade to do that. So some more rock under the pavement. There might have been a pipe change or two, but as far as the major issues, then, you guys said rock was 20 feet and 70 feet. We're going to have to redesign it, that type of thing. We've been fairly fortunate in this one. This one went pretty smooth in that respect.
Thanks, everybody.
Thank you.